Hey, it's Miss Phelps, and tonight we're actually going to start talking about something new. And there's quite a bit of notes, but hopefully you have your notes sheet with you and you can fill in the blanks as we go. So tonight we're talking about angles, and I want to get started. Some of this is going to be very familiar to you because you've done it before, but some of it's going to be kind of new. So to start with, an angle is two rays that meet at a point and extend indefinitely. So basically you have a ray going one direction and another ray going the other direction, and where those two begin is where they form an angle. And the two rays are the sides of the angle, and the point at which they meet is called the vertex. Hopefully you've heard of some of this vocabulary before. An angle separates the plane into the interior region, the exterior region, and the angle itself. If you hold on a second, I'll show you an example of that. Angles are measured in degrees using a protractor. We're probably going to be doing this tomorrow, so get ready to make sure you bring your pencil and some paper, because we're definitely going to be working with our protractor and the compass tomorrow. Alright, and angles with equal measures are called congruent angles. Okay, so here's some examples of those things that we've just talked about. Okay, so first of all, I have a ray going up, a ray going to the right. Where those two meet is point B, and that's actually my vertex, okay? And over on this side, I have angle P, but angle P actually forms two different angles. It's MPN and angle 1 also. So I actually have my interior here. The outside of the angle is called the exterior region, and right where my lines are is the angle itself. Okay? Alright, so let's go on. Okay, an angle can actually be named three different ways. The vertex point, if there are no other angles at the vertex that could be confused. So for instance, here this would be angle, you could call this one angle B. But over here on the right, I could not call this angle P because I actually have two different angles here on the top and this angle 1 down here. So you could not actually call that angle P. Alright, if I go on, I could name it by three letters with the vertex as the center. Now that's important. You can't have an angle with the vertex in any other spot except in the center. So this top one would be angle MPN, with P being in the middle because that's where the vertex is at. And this bottom one would be NPO. Now I could also say it as OPN as long as the P is in the middle. Alright, and the last way is if you have a small number that's given inside the angle. For instance, I have this 1 right here. So that it could also be named angle 1. Alright, let's keep going. Oh, I actually had an example, and it says give the possible names for the figure in, or I'm sorry, for the angle in figure 1. So let me go back up just a little bit. Okay, so I said it could be named three ways. Sorry about that. There's my mistake for the night. Okay, I could name it angle B because there's my angle. I could name it angle ABC. And this one doesn't have a number in it, so the only other way I could name it would be to name it backwards, so it would be CBA, okay? Alright, now we can go on. This next section should be incredibly familiar to you because you have been doing this since I think about the 4th grade probably. We're going to talk about angle classifications, and the first one is an acute angle, and hopefully you've seen these before. But an acute angle is an angle that's between 0 and 90 degrees. It's less than 90. So that could be anywhere from little bitty tiny up to 89 1.5 degrees would still be an acute angle. The next one is a right angle, which that one is also equally familiar to you. A right angle is exactly 90 degrees, and it forms perpendicular lines where the two rays meet. Now, most of the time it's shown to you with the little box in the angle, so you know that it is a right angle. Alright, let's keep going. Okay, the next one is an obtuse angle. And obtuse has to be between, it's more than 90 but less than 180. So that's obtuse. Alright, and then the last one in this set is called a straight angle. Now most of you have heard of the other three, but not the straight one. A straight angle actually looks like a straight line, but it has a vertex in the middle. So this is what a straight angle would look like. There's my vertex right there in the middle, and it's basically, like I said, a straight line. But it's also opposite rays because they're going in opposite directions. Okay, so that's your front page. I want you to flip over to the back of your notes and let's do the second half. Now, the first half was angle classifications. Those were pretty familiar to you, I hope. This next set is angle relationships. And here's the first one. The first one is adjacent angles. And adjacent angles are coplanar angles that have a common vertex and one common side, but does not have common interior points. So if you'll notice on here, they share point A, that's their vertex, and ray AC is common for both of the angles, okay? So one of my angles is BAC, my other one is CAD. So they both share AC right there, okay? Alright, the next one is called vertical angles. Now, vertical angles, for most people, they just call them opposites. They're two non-adjacent. Remember, adjacent means side by side, like they're neighbors. But these two are not side by side, and they're formed by intersecting lines. So for instance, I've got 1, and straight across from there's 2, so 1 and 2 are vertical. And then there's 3 and 4. 3 and 4 are also vertical. Alright, my next one is a linear pair. And hopefully you know two things about it. First of all, linear means that it's going to be something to do with the line. And pair means two, so it's actually two angles that together make a line. So as you see here, angle 1 and angle 2 form a line. Okay, the next one is complementary angles. Just hold on. Alright, complementary angles, the sum of the two angles add up to 90 degrees. Now, if you'll notice, these, how a linear pair, these are actually stuck together to form a line. Complementary angles do not have to be together, but they could be together. So, for instance, I've got this one that's 60 over here, and then I've got this one that's 30. But together they add up to 90, so I know that they would be a complementary pair, complementary angles, even though they don't share a common ray. And then the last one is supplementary angles. Supplementary angles are very similar to a linear pair. They're two angles whose sum adds up to 180 degrees. Now, it could be two angles or it could be 200 angles, but together, all of them, their sum has to add up to 180 degrees. And also, unlike a linear pair, they do not have to be stuck together. They could be separate angles that add up to 180. So that's the difference. And tomorrow, I'm going to ask you to compare and contrast a linear pair and supplementary angles and tell me what is similar about them and what's different about them. I hope that you've had a great evening, and hopefully most of you have come to open house with your parents, and don't forget, make good choices.